And welcome back to my channel, and welcome back to the Electronic Experimenters Kit, experiment number 6, the Astable Multivibrator. Right, here we have the Astable Multivibrator on my new Experimenters Kit board, and we have little standoffs to hold the board up straight so the components don't wobble. We got little power blocks that are wired in now, so it's moving along. We have the resistors, the LED, the capacitors, the transistor. This one here is basically just a crosswise connection so that it connects that point to that point and to that point, and it also go over here if you want. And the same with these ones here. You can just use them to do two connections. So we'll bring the circuit up and we'll have a quick look at that. So we'll pop up the circuit. There's the circuit, and as you can see, it pretty much resembles the board. The only difference on the board is this bit here is this bit here, but the transistor is pointing that way. It should really point in, on the drawing the base is on this side, but due to my board, these components, the base is always going to be that side. So the circuit looks a little bit different. If it was pointed here, of course that jump wire would just go down to here and it would be the same as the drawing. But so that's the only difference, it's facing the other way. So I'll pop the drawing back. Let's think about the circuit when LED 1 is on and LED 2 is off. Well, we need a starting point, so let's start here. The voltage on the junction of C2 and LED 2, it quickly reaches VCC because Q2 is off. And LED 1 is only lit when Q1 is on. So we know the base voltage for the transistor to be fully on is about 0.6 to 0.7 of a volt. So this means the voltage at the junction of R3 and C2, and so the base of Q1, is 0.7 volt. C2 will be charging as the other side connects to VCC through R4 and D2, so it will be charging and the voltage across it will be rising. Now let's look at the voltages around Q2. The voltage on the junction of C1, R2 and Q2 base is somewhere below 0.7 of a volt, as Q2 is in the off state, but it's increasing as current flows into C1 via R2 when the left LED is lit, because this side is obviously grounded via the transistor, so current's flowing down here. And then we get to the turning point. So when the voltage at the junction of C1 and R2 and the base of Q2 it rises and it gets to about 0.7 of a volt, Q2 starts to conduct, and the current starts flowing from the collector to the emitter, lighting LED 2. But when Q2 turns on, an interesting thing happens across C2, which is the voltage across it is VCC this side, or was VCC this side, and VBE of Q1 this side. So about 4.3 volts across the capacitor. Now that voltage cannot disappear. The fact that this is coming down to 0 volts, that voltage across the capacitor cannot disappear, as it's related to the charge on the capacitor, because Q is equal to Q divided by C. So thinking about it, we had 0.7 this side, VCC on this side, but now the side with VCC has suddenly gone down to 0 volts, but the voltage across the capacitor remains the same. So this junction effectively jumps down to about minus 4.3 volts, taking the base of Q1 quite negative, turning Q1 off quite rapidly. So Q1 is turned off because it's now reverse biased. But, and there is a but now the voltage on C2 starts to charge via R3, and so the voltage on the base will start to rise, and when it gets back to around 0.6, 0.7, we'll be back with Q1 on and Q2 off, and it will do this infinitum till while the power's there. This will just flip backwards and forwards, and the timing should be determined by the values of R3 and C2 and C1 and R2. If R2 and R3 are the same and C1 and C2 are the same, we'll have a 50% duty cycle. If they're different, then of course the duty cycle will vary. Now if we go back and look at the circuit, so we'll lose the display, we'll look at the circuit, and I'll just move that to a collector. Right, there we see it flashing. We'll bring up the scope, and here we can see that we have, bring my pointer in, one cursor at 0 volts, the other cursor at the top of the trace, and down here the difference in voltage is 3.5 volts. So we've got 3.5 volts transition across the transistor as it's flashing away merrily. And then to demonstrate what's happening on the base and the fact that the voltage is going negative, we'll bring that down, put it on the base, bring the trigger down so it triggers, and now you can see it's going below 0 volts. So excuse my arm while I reach over and so here we can see that the base is going up to 0.7 of a volt when the transistor is fully on, and then when it switches it's jumping down and it's going 1, 2, excuse my hairy arm again while I bring the cursor down. So there we're jumping down to about, right here we can see that the base is jumping about 2.84 volts negative. So we can see that the base is being driven to saturation, or 0.7 of a volt, and then when it's turned off it's very quickly hit down to minus 2.8, and so it really turns the transistor off hard. And then you can see there's the RC network charging up to the point where it gets the transistor turns on, and then whack, it stays there. And then when the other transistor turns on, bang, it's down. And just to show that it's kind of symmetrical, we'll put it on the base of the other transistor. Yeah, and that's identical. And if I move it to the collector, there it is, the same as on the other one. So quite a long-winded video, but I hope it helps. I hope you found it interesting, and I look forward to seeing you all on experiment 7. So if you like what you see, subscribe, click on the notification bell, click on the like, and please comment. You know, if you think I've made a mistake or you want a bit more of an explanation, feel free to comment down below and I'll do my best to answer your questions. Just a bonus one to show that I've swapped out one of the 100Ks for 10Ks, and as you can see now it is no longer a 50-50 duty cycle. It looks a bit like 10 to 1. And you go on the base, that's not the base, that's the base. Well, there, see, much shorter on time because the other one is charging up far faster, as you can see by that. It's a much faster charge up time, so the on is a lot longer than the off. Just thought I'd show that as a bonus.